This conference will now be recorded.
Yeah, can you hear me, guys?
Yeah, then now I'm able to hear you.
So today we are going to speak about dependency management, in Terraform. Generally, while creating resources, Terraform can select any order. Okay. So, for example, yesterday we created a VPC, two subnets, two route tables, one gateway, one security group, one key pair, and one virtual machine, one EC2 instance. Okay. So here, based on our configuration, Terraform can create resources in any order. That is completely implicit dependency. Okay, how Terraform is going to create, okay, and what is the dependency, how it is follow the structure, that is completely, it is up to Terraform. Okay, sometimes we need to create one resource after another resource. That is explicit dependence. So there is two dependency mechanisms. One is implicit dependency. Here, Terraform uses the order of the resources. And when it comes to the second kind of dependency, that is explicit dependency. Okay, here we write the order, okay, in which all the resources are created. All the resources are created. This is about explicit dependency. Okay, implicit dependency, it is not in our hands, but explicit dependency, okay, it is in our hands. So we can specify what resource must be created first, what next. Okay, what is the resource that is depending upon other resource. Okay, suppose I want to create one VPC, two subnets. Now I can create a VPC. Now at the time of creating subnets, I can specify that the subnet depends on VPC. When no VPC is created, when no VPC is created, subnets are not created, because without the VPC, no subnets are existing. In the same way, I want to create VPC first. Then after I want to create subnets. Then after I want to create okay gateway. Okay, like this I can specify order. That is explicit dependency. Explicit dependency. Now let us open this Terraform meta argument dependency. Depends on. So depends on is a meta argument. Yesterday we have discussed count is one meta argument, and here. So first, yeah, so if you look at this resource, First is creating a IAM role. Okay, IAM role is nothing but it is a policy that is given to one AWS resource. And once my IAM role is created, okay, so here we are creating these resources. Resource IAM policy. Okay, IAM policy. And here AWS instance we are creating, this is AMI. And here, are you seeing here? Depends on AWS IAM role policy dot example. Okay, while creating instance, okay, is specifying a dependency on policy, IAM policy dot example. This is IAM policy dot example. This one. This is explicit dependency. Okay, first we are saying that first create this IAM role, then create this AWS instance. So if no IAM role is created, okay, instance should not be created. That is a dependency between two resources. Okay, in the same way, suppose there is another example I can give. I want to, sorry, this is explicit, not implicit. Explicit. And here I want to create a virtual machine first. Once a virtual machine is created, I want to create a hard disk. Hard disk I want to create, and elastic IP address also I want to create. Okay, so if elastic IP, so if no instance is created, I don't want to create hard disk and elastic IP. Okay, so that is a dependency I want to create between resources. Okay, now, so where is our folder? Let us write some dependency information. For our folder name is Terraform 6th December. This is this one, right? Good.
This
You
one.
look here. Code dot. Where's BCP? Okay. Now let us create one file. This is depends on .tf. And let us take one example from my previous batch. Let us look at this example. This is because accurate example. First, I am creating a instance. Okay, for creating instance, we know that we need AMI, instance type, and availability zone. Okay, availability zone is East, US East to A. It is Ohio region, Ohio availability zone. Okay, and then we are creating a virtual volume. So this volume creation depends on instance. So when instance creation is successful, okay, here volume is created. Okay, volume with 10 size, 10 GB, and here volume and instance both must be there in the same availability zone. That is a rule in AWS. Okay, your hard disk and volume both must be created within same availability zone. Okay, that is why we have mentioned US is to 2A, here also is to 2A. And this is going to create instance, and this is going to create a value, and this is going to create elastic IP. Okay, now elastic IP creation depends on two resources here. Okay, what are the two resources on which it is going to be depending? One is I3. I3 means this is instance and volume 1. Okay, so depends on array, depends on is a array type variable. Okay, so it can take one resource or multiple resources also. And after that, okay, once my elastic IP is created, okay, it must be attached to a virtual machine. Okay, so how to attach here? Instance equal to AWS underscore instance I3 dot ID. Go to this instance, it will be attached. Okay, now let us take this. Now, what is our image ID? Here, this is the image ID, right? Here, this is the image ID. And here, so it depends. My elastic IP is depending upon two resources. One is I3, other one is hard disk. Okay, so that means first Terraform is going to create I3 this instance, then it will come to elastic elastic block store, that is hard disk. Okay, while creating hard disk, it is going to see whether I3 is created or not. So when I3 is created, then it will create value, and once these two resources are created, then it will come to elastic IP. So in the elastic IP, it is going to look for I3 and V1. Okay, V1 is value 1 and I3 is instance 1. Now let us validate this. It's unclosed. Okay. Okay, it is success, right? Let us activate my credentials. Let us go to IAM, users, Terraform user, security credentials, the access keys, say activate. Now let us say Terraform plan. Okay, so it is clearly telling that it is about to create three resources. Okay, one is elastic IP, and other one is hard disk, other one is resource. Sorry, instance. Now let us create it. Terraform apply auto approve. So instance was created successfully. Now it is creating value. Okay, value creation was also successful. Next, it has created elastic IP. Now let us go and see whether three resources are created or not. Go to EC2. And are you seeing one instance is running here? Here we did not give any name for this. So if I select this, and here in the networking section, you are able to see this option, Elastic IP. Are you seeing Elastic IP? 3.23.181.237. So it is the same as public IP address. Okay, so generally when you don't allocate Elastic IP address, and when you are creating a virtual machine with the public IP address, what happens here between startup and shutdown? Okay, your public IP address might be changed. But when you allocate Elastic IP address, okay, this address will not be changed. This is constant forever. Okay, till you terminate the virtual machine, it will be permanent. It will not be deleted. And where image is created here, sorry, volume is created. So here, if you want to see the volume, here this is a section, Elastic Block Store here. So in all Elastic Block Store, click on volumes. So we volume with what capacity we have created? With 10, size equal to 10, right? And I did not give any tag name. Okay, nothing will happen. It is easy to identify. I think this is created just yeah. One is 2050, other one is 2051. These are default disk. Okay, default disk, default size in AWS is 8 GB. One additional disk is 10 GB. Here 10 GB volume with 10 gigabytes. Okay, was created. Okay, yeah, the region is US East 2A. Both are created in East 2A. Okay, yeah, this is how you can create a dependency between any two resources. So is the concept of dependency management is clear, guys?
Sir, actually, I have one doubt actually.
Yes.
Mm. So dependency means if suppose I'm creating one VM, in prior to that I wanted to create a VPC. Based on that, I wanted to create a VM. So that's also possible. Right? First create a VPC and then we can create a VM based on the VPC. That is the thing is called dependency, correct?
Yes.
Okay. So here, the while creating a VM itself, it will create a hard disk, right? So how the dependency you are telling that's a dependency actually?
No, no, no. What hard disk I am saying that is extra hard disk. Okay, one default hard disk was created. Okay, when VM is
Oh,
created, one default hard disk is created, and
okay.
in the script we are creating one
Hmm.
additional hard disk here.
Oh, okay. Okay, sir.
This is additional hard
Okay, sir.
disk. Okay, so with
Okay,
this
okay,
machine
sir.
with i3, one default hard disk is created with 8 GB, and we are creating one more extra hard disk, and we are attaching this hard disk to this virtual machine.
Okay, sir.
Okay, so is my point clear? Okay, that is
Clear,
why
sir.
it is showing two hard disks, right? Is it not showing two hard disks here?
Yes. Yes. It's to a disk and okay, okay, with the same instance. Okay, sir.
Shiva, can you go to that code?
Yes. Mm.
What is the line number 18 here? What it is representing it here? Line number 18.
Here this is instance equal to. So once my elastic IP is created,
Mm-hmm.
definitely we have to attach this associate this elastic IP to the virtual machine,
Okay.
because
No.
the purpose of elastic IP is okay. This will be existing with a instance. Okay, the
Yeah.
purpose of elastic IP is okay to associate with instance only. That is why this instance equal to okay. Once my elastic IP is created, I
Mm-hmm.
want to attach this elastic IP to my virtual machine. So that is why instance equal to okay. To which instance you want to attach it? AWS underscore instance is a resource type. I3 is a instance name. Are you seeing I3 here?
Yes.
I3 dot ID. ID is a attribute here. Did you get the point?
Yes. Yeah. So one more question, Shiva.
Because
So
actually instant, yeah, in the elastic IP will not be existing individually. Okay, so the purpose of elastic IP is only to associate with virtual machine.
okay.
Okay,
Okay.
is that clear?
Yes. Yeah. Yeah.
Okay. Now, yesterday we have discussed count option. So using count option, you can decide how many times a specific block has to be executed. Okay, in any cloud, if you want to create multiple resources, there is only one way, like count equal to something. Of course, for each loop is also there. Okay, we will discuss that loop also. For each loop also there, using that loop also we can repeat a particular block for many times here. Now, how to use conditions in Terraform? Okay, so generally in C++, Java language, so we are going to have conditions, right? In Terraform also, we are having conditions. Terraform conditions. Now, how we can write conditions in Terraform? So generally, when it comes to C++, we are going to write conditions like this. Suppose here A equal to 10 and B equal to 20. I want to calculate, I want to decide the biggest value of 2. Then simply I can write a condition like this here. If A is greater than B, and I can write big equal to A. Else, okay, here big equal to B. This is one way. And here we in C++ we have a option that is ternary operator, and we can write like this here: big equal to condition. So what is the condition? A is greater than B colon. Okay. So if A is greater than B, the value of A is assigned to A. Otherwise, the value of B is assigned to B. This is ternary operator. Okay. So in the same way, in Terraform also we can write conditions. So how to write conditions in Terraform? Let us see. Terraform conditions. Conditional expression. Now here this is conditional expression. Variable dot A is not equal to this one. Okay, here we have many types here. Okay, here this one. Variable dot example. Okay, this is going to check whether variable dot example. So if the variable dot example value equal to okay, so true. If this condition is true, 12 is assigned. Otherwise, hello is assigned. This is one more condition. Here this is a general form. This is a condition. Okay, if this condition is evaluated true, okay, this value will be executed, and otherwise this value will be executed. Now based on this, I want to apply. Okay, I want to apply this Terraform conditions to a simple example. Okay, now one activity we are going to do. So here we are going to take environment value. Generally, in every software industry, we are going to have multiple environments like dev environment, QA, production environment. So only production systems will be having elastic IP address. Only production systems will be having public IP address and elastic IP address, because production systems can be accessed from internet. That is why every virtual machine, okay, must be having elastic IP address in production environment. Now here we are going to take a environment value from keyboard. Now here the environment can be either dev or QA or production. That can be anything. So if the environment value equal to, okay, like this I want to write, if environment equal to dev or prod, environment equal to prod, okay, I want to create elastic IP, and that elastic IP must be assigned to a virtual machine. Otherwise we don't create elastic IP, and we don't assign this elastic IP, okay, to a virtual machine. That is my condition. Okay, how to write this? So did you understand the use case, guys? Environment value we are going to accept from keyboard. So if the environment value equal to prod, then what is that you want to do? Create a elastic IP and assign EIP, elastic IP, to a VM. Okay, else. Okay, in the second part, what I have to do? Don't create any EIP, elastic IP. This is my condition. Okay. Now let us define one file. Now let us sorry, this is condition, or you can write prod.tf. Okay, here I am going to take a value, variable name equal to environment, description, enter environment, either dev or QA or prod. Okay, now I want to create a virtual machine. Okay, so how to create a virtual machine? To create a virtual machine, we know this is a code generally. Okay, so you can write the code, or directly you can, where is prod, and instance type equal to T2 micro, associate public IP address, subnet ID is not required, and even I'm not giving key name also, because we are not going. Okay, security group is also not required. Next thing, so how to create elastic IP? To create elastic IP, in the previous script, we have written a resource block, right? So where is the resource block? Depends on this one. Remove this depends on. Here I am going to write count equal to, okay, variable dot env. Okay, variable dot env. Okay, so when variable dot env equal to prod, sorry, prod, then count value will be 1. Otherwise, count value will be 0. Okay, what is the meaning of this line? Here web server is created and instance type equal to T2 micro and key name is also AWS key pair. Okay, this is key name, any key name you can give. And when elastic IP is created here, whenever count value equal to 1. Okay, so when count value equal to 1, whenever environment value equal to prod, then count value equal to 1, otherwise count value becomes 0. Means this block is not executed. Okay, now let us validate it. What is this? An argument must end with a new line.
So, so you're giving like var dot environment equals to, is that right sentence, Shiva?
Okay, so you are saying like this, double equal to, right?
After environment, you're passing again equal to, right? Yeah.
Let us see.
Jeez.
Variable
Colon.
dot. Okay, let us check the syntax of count. Okay, after condition there is a question mark. What is that missing? Variable dot. Okay. Variable dot environment equal to this one, and I think
It's like after prod is a question mark or what?
yeah. After prod question mark.
Remove the colon, right?
There is no colon.
I think it is bath. Can you put double equal stance here
Okay.
after environment?
I3 dot ID. 14th line number. Okay, this is web server, not I3. The deployer is also not there. Okay, let us comment it. Terraform. apply hyphen auto approve. Okay, so I am giving prod. Now it is creating instance first. So it is planning to create two resources. One is elastic IP address, another one is web server. Okay, two resources it has created. So what is the instance ID that it has created here? Instance ID is I089. It ends with 6B92. Go to instances 6B92. Okay, select this. And when it comes to networking, so in the networking, public IP address is 18.224.175.89. Here, elastic IP address is also same. This one. Are you seeing elastic IP address is created here? Now let us destroy and let us create other. This time I am going to give a value other than prod. See what happens. I am going to give dev environment. Are you seeing it is creating only one? It is not creating elastic IP. Now if you refresh this page, it is terminated. This is a new instance that was created here. And here there is no elastic IP. In the networking section, public IP address is created, but there is no elastic IP. Are you seeing no elastic IP addresses are associated with this instance?
No.
That's right. So here out of three provisioners, yesterday we have discussed one provisioner called remote EXEC. Okay, remote EXEC is a provisioner which is going to execute a provisioning script, okay, in a new resource that will be created by Terraform. And there is one more provisioner, that is file provisioner. And yesterday I told you, right? And suppose there is some artifact that you have created in your build server that I want to copy from your build server to your another new server, we can use file provisioner. Okay. So how to use file provisioner? Let us see. Here, this is yesterday's remote exec, right? Where remote exec is there?
Abo, below the prod one.
Yes. Remote exec. And in the place of this one, I will write local exec. I don't write any output block. This is local exec dot tf. Remove this. The place of this one, I will write file exec. File. So for file, it requires only two options. One is the source and the other one is destination. Okay, let us see the syntax of file provisioner. Terraform file provisioner. So this is file provisioner. Connection is normal. Okay, so you can connect to the virtual machine. Connection information is common, and these are the, so you can use as many provisioners as many in a single instance block. Source is this one, destination is here, and here source is this one, destination is here. Okay, source and destination. Okay, let us try this. Source equal to this is a Windows virtual machine, right? How can I write source? What are the files it is having? That's a vpc.tf. vpc.tf. And what is the destination? Destination is home Ubuntu, and the destination we have to give file name also, file.log, or you can simply you can write this one, Ubuntu. Okay, so here say key name we have given, and security group also we have given, and AMI instance type associate public IP address, and here username equal to Ubuntu, and key name equal private key equal this one, and provisioner equal to, let us close, I think one more bracket is required, right? Let us
So it looks
validate
like
this.
it's gonna throw error, Shiva.
Okay, why?
I don't know, like
I
on
think
the
in prod.tf,
it is on the line number 19, right? So it is showing up some error.
local exec,
Local.exe
line number
on the
9.
line 19 destination under before home, right? It is showing up some.
double quotations.
I think so. Yeah. Yeah.
Terraform, apply, auto. Okay, one added. Let us see what is added. What is the instance ID?
1E, ending with 1E.
151E.
Yeah, the
What
third
is
one.
that?
Third one.
Can't connect.
Can't be established.
Sudo root man. Is not copied.
Can you give sudo hyphen I? Sudo space hyphen
Mhm.
I? Sudo space hyphen I.
I.
Yeah, I. Enter. Yeah, now can you execute?
Yeah, actually, I have given path. Which path I have given? Home Ubuntu. apc.pf. Is nothing is changed here. C file apc.tf is there, right? apc.tf is there. Is not copying. It should copy. Should see. Previously, many times I copied. Why it is not copying now? apc.tf. If it is a source, destination is /home /ubuntu vpc.tf. Syntactically, it is correct, right?
The .vpc is there in the root actually? Is it that file is in the root?
No, it is there in the current directory. Where
Then it
from
should
where I am
be
running.
then it should not be dot slash. It should be like given the file name or not. It's can you give pwd sir? Pwd pwd. Yeah, enter. It's under D Terraform Durgasoft 06. So can you copy this path in prior to this vpc.tf so that it will copy?
No. Here, see, here they have mentioned this one, right? Source equal to directly as specified.
Okay, sir. Uh,
Or
you did,
saying like this, right?
yes, sir. You did get dot slash. Dot slash means it's yes, sir. Yes, correct. You mentioned this. Not not D. That Terraform Durgasoft 06. That also fine. Yeah. Yes, sir. This should be fine, sir. Yeah, correct. Slash vpc.tf.
Is it front slash or back slash? That is also important.
Forward slash only.
Forward slash.
Slash only. Backslash. Not taking.
No, V is not a valid escape sequence.
So
Which
instead of
one?
D, you can give the same path, sir. Slash.
This one.
Yes, yes,
Yeah.
yes.
Okay, but he has given D colon
So
front
D
slash he
colon.
has given.
Oh, okay, sir.
See. Copying. Should copy because it is the first time I am seeing. Because many times I did this. Source equal to slash etc. Actually, when I give this, I did not in the previous batches. Even I did not give this complete path. I have given only dot slash
Ubuntu.
destination equal to home ubuntu vpc.tf. Let us see this. Let's remove this. Let us completely destroy. Let's see what happens.
Okay, so
Could you show me the code, sir? Oh, okay.
Six year double six. Simply it is ignoring. Okay, I will check it in offline. Why to waste the time? I will check it in offline. From your side, I will also test it because this is the first time I'm facing this problem because many times, okay, so I did this, but why it is not copying, you will see.
Oh, okay, sir.
Okay, I will, I'm uploading these two files in the drive at presently. December. What is our folder? One is local exec, prod, that depends on. I uploaded notes also, and I will also upload today's in online 13th December. Okay, so recording they will upload because cloud processing it takes time. They will upload the recording. From my side, I uploaded notes. So before that, let's destroy everything. Done. Case deactivate. Okay, guys. Tomorrow meet again. Thank you.
Okay, thank you, sir. Thank you.